Hi everyone, for this video we're doing grade 12 control test from Limpopo provincial paper. So this paper consists of number patterns. If you just go back to the paper, it consists of number patterns and Euclidean geometry, circular geometry, questions. So this is the first video, so I'll be doing question 1 with 6 marks, so it's gonna be fairly quick, just number pattern, and then I'll go in that order. So let's go. So question 1 is number pattern, sequence, and series. So there's a couple of things that you need to know before you start understanding question 1, right? First thing is that you need to know is you need to know something called quadratic sequences, right? Quadratic sequences is I'm gonna give you notes just based on this example, but they're applicable to every question that you're gonna get, right? So for example, they say here you are given a sequence, so you sequence start with 0, so let's just write from here, start from 0, and then the next term is 5, the third term is 16, the fourth term is 33. So the sequence, let's say it ends here, just 4 terms, right? So what I just said is this is the first term, this is the second term, this is the third term, this is the fourth term. Okay, and so what you need to know with the quadratic sequencing, you need to find two differences, right? You need to find what you call the first difference. So the first difference is you take the second term minus the first term, which is 5 minus 0, that's 5, and third term minus the second term. You can use a calculator, by the way. You are allowed to use a calculator, or you can actually also exercise and use your mind, which is really recommendable. So 16 minus 5, that is 11, and then you can take 33 minus 16, that is 17, right? So that's what you call, this is your first difference. So again, this is what you do for every quadratic sequence, applicable for every quadratic sequence. And then you check your second difference. Second difference, again, you say t1 minus, say 11 minus 5, so 11 minus 5, that is 6, and then again you say 17 minus 11. What is 17 minus 11? 17 minus 11 again is 6. And what you should expect with the second difference is that the second difference, you're always gonna have the same number. The number is gonna be the same. The second difference is constant. Okay, you need to know that the second difference is constant. We can actually write that down. Second difference is always constant, meaning the second difference is always going to be the same. And then the formulas that you need to know, that you need to remember, what you need to remember is this value here, 6, is equal to 2a, right? This value here, now it doesn't matter what value, after doing this whole thing, it doesn't matter what value it is, that value is always going to be equal to 2a, always going to be equal to 2a. And then this value here is always going to be equal to 3a plus b. Okay, doesn't matter what value is. When you're told this is a quadratic sequence, it's you first do your first difference, do your second difference always constant, and this value of the second difference is always going to be 2a. This value of the first difference is always going to be 3a plus b. Okay, and then this value is always going to be a plus b plus c. this value is always going to be a plus b plus c. Doesn't matter what it is. So the first term is always going to be a plus b plus c. Okay. Why do you need this? It's because with the quadratic sequence, we have what you call a quadratic formula. Okay, so a quadratic formula is Tn is equal to a n squared plus b n plus c. It's a quadratic formula. This is a quadratic formula, right? So these equations, 2a is equal to this, 3a plus b is equal to, it's going to help us to solve for a and b and c. That's why you need to know this, because it's going to help us to able to solve for a, to able to solve for b, to able to solve for c. They are always going to ask you the value of a, the value of b, the value of c. And luckily, with 1.1.1.1, they are asking us to show that the nth term, so when they say nth term, they're talking about Tn, that's what they're saying, the nth term, Tn, show that Tn is given as follows. So they want us to prove that Tn is equal to 3n squared minus 4n plus 1. So you see this is Tn is equal to, so basically this is an squared plus bn plus c. So they're asking us to prove that a is equal to 3, b is equal to -4, and c is equal to 1. That's basically when they want us to prove. They want us to prove that if a is equal to 3, b is equal to -4, and c is equal to 1. Alright, so we're going to do exactly that. How do we do that? Again, that is the reason why you need to remember this relationship, right? So 2a is equal to 6. 2a is equal to 6, so you're solving for a. So what you're going to do is you're going to divide by 2 on both sides. Why are you doing that? It's because you're solving for a, right? And then 2a over 2a is 1, so you're going to have a is equal to 6 over 2, that is 3. So a is 3. Okay, so that's exactly what we're trying to prove here. A is 3. Okay, now let's go to the second relationship. 3a plus b is equal to 5. So 3a plus b is equal to 5. Again, we already know what is a. What is a? A is 3. 5. So 3 times 3, that is 9. 5. And then you can take the 9 to the right hand side, it becomes negative. So you're going to have b is equal to 5. The 9 becomes negative, so you're going to have 5 minus 9. So 9, so 5 minus 9 is -4. 5 minus 9 is equal to -4. So b is equal to -4, and we can see we're already proving that. That's correct. So this is correct, this is correct, and the last relationship is a plus b plus c is equal to the first term. So this is a plus b plus c is equal to the first term, and the first term is 0. So we already know a is 3, we already know b is -4. 3 minus 1, 3 minus 4, which is equal to -1. My mind was already ahead. And then you take the -1 to the right hand side, becomes positive, so you're going to have c is equal to +1. So this is what this is already what they want us to do. And then you can now say, okay, therefore Tn is equal to a is 3, so you're on 3n squared, and then b is -4, so you have -4n, c is equal to 1, so you have +1. Voila. So you've proven what they ask us to show here. Show that the Tn, nth term, when they say nth term in number pattern, I mean Tn is given by this equation, and that this was just 4 marks. So you're gonna get marks. Show you. So it's 4 marks. So it's 1, 2, 3, 4. These are your marks. Okay, 1, 2, 3, 4. So does this mean this is not important? This is important. This helps you to able to get this, right? So do this first, and then you can able to derive A, B, and C from this. Okay. 1.1.2. So with 1.1.2, let me wrap this off. With 1.1.2, determine which term in the sequence is equal to 5,896. Now, let's read the question again so that you understand. We said when they say nth term, they mean Tn. But when they say term, they mean n. Okay? So they want us to find n. Again, just a reminder again, we know the formula of a quadratic equation is Tn is equal to an squared plus bn plus c, and we were given sequence 0, 5, 16, 33, and from this sequence we're able to derive the general term of this sequence, which is 3n squared minus 4n plus 1. Okay, so question 1.2 says now determine n. When I say term, mean n. Determine n in the sequence. Determine which n in the sequence is equal to 5,896. Okay, so what does this mean? So they want us to solve for n in this equation, right? So what is 5,896? 5,896 is our Tn. Tn is 5,896. How do you know that? Let's read again. Determine which term in the sequence is equal to 589.6. So they want us to know which term in the sequence is equal to 5,896. So they want to know which term in the sequence is equal to this number. And this number is Tn. Tn is equal to 589.6. So because they wanted to solve for n, what you're going to do is Tn, you're going to say, okay, cool. We already know that this is our general equation of the sequencing, and Tn is 5,896. And then we're gonna able to solve for n, right? So you can take the 5,896, put it into the right hand side, becomes negative. So you're gonna have 0 is equal to 3n squared minus 4n plus 1 minus 5,896. So 0 is equal to 3n squared minus 4n. So 1 minus 5,896, that is minus 5,895, right? I love to write this way though. 3n squared minus 4n, just preference, nothing special. This is the same thing. And then from here we can now use what you call a quadratic equation, right? Remember, we're dealing with quadratic sequences, right? What is a quadratic equation? Just a reminder, you already know quadratic. Well, before I go there are so many ways to solve this problem from here. Many ways. I know 3, but I'm going to teach you a quadratic equation to use it every time. Why? It's because it's an equation that has been given for us to use, so you're not gonna lose marks by using that equation. It's easy to use, and you most likely to get it right than other methods. Other methods, they're almost difficult. Some students, they don't get it right. So for you to always get your answer correct when you are in this situation like this, where you have a quadratic equation, right? This is a quadratic equation. Again, how do we know it's a quadratic equation? A quadratic equation is when you have n squared. So your first, your highest order is 2, right? The highest order of exponent is 2, right? Then is a quadratic equation. But if we didn't have 2, so if we had like something like p squared plus p plus 1 is equal to 0, this is a quadratic equation. But if you have p plus 1 is equal to 0, this is not a quadratic equation. It's a linear equation. Why is not a quadratic equation? Because the highest order of exponent is not 2, is 1, right? But if you have p cubed plus p plus 1 is equal to 0, what is this? This is not a quadratic equation. This isn't this is a cubic equation, because the highest order is not 2, so it's 3, right? Just a revision on this. Just know, when is your equation a quadratic equation? Quadratic equation is because the highest order of exponent is 2. Okay, then it's a quadratic equation. Then you can use now your quadratic formula to answer your question. So let's go. So quadratic formula says you have n is equal to I can just use black. I can use this color, is fine. N is equal to minus b plus or minus b again squared minus 4ac divided by 2a. What is your b? This is your a, this is your b. Remember, b, all this -4, and this is your c, this is all of c. Remember the quadratic equation. The quadratic equation is a n squared plus b n plus c. So this is your a, this is your b, this is your c, right? Then you substitute this in your equation, you get your answer. So n is equal to minus b is -5895 plus or minus b, again -5895 squared minus 4. This is times a, what is your a? 3 times c. Oh my god, that's wrong. Wrong. Excuse me, that's not your a. I'm sure others, I'm sure you saw my mistake, right away. So n is equal to minus b is 4, not 5,895. B is 4, so if it's minus 4 plus or minus, again minus 4 squared minus 4 times a, which is 3, times c, which is minus 5895. This is all under the cube root, and then a is 3 again. And then you can punch this in your calculator the way it is, but instead of writing plus or minus, you can start with the plus and then get your answer, and follow with the minus and get your answer. You're gonna have 2 answers here. So you have -4 plus -4 squared. Punch it the way it is and you calculate the way you see it. 5895 divided by 2 times 3. So if you start with the plus, you're gonna have 45, right? N is equal to 45, or n is equal to, now change the plus to a minus. You're gonna get -131/3. Okay, so what you need to know here is the term n. This term here, n, there are rules about it. Number 1, n can never be negative, right? N can never be negative, and then n can never be let me put it in this way. n is always positive. Always positive, right? Always positive. Can be 0. Can it be 0? No. N can never be 0 again. So n is always positive. Can never be 0. It can never be negative. Okay? Remember that. And n is a positive integer. So n is technically a positive integer. So it's a whole number. It's not going to be a fraction or a decimal. It's not going to be that. So, for example, you see that in this case, n is a fraction here. So, this is not applicable in our answer. So, our answer is 45. N is equal to 45. Not this. Why not this? Because this is a fraction, number one. Number two, it's negative. N can never be negative. N is always going to be positive. Why is that? Because remember, you're looking at n is t1, the first position, that's n. 1 is n. t2, that 2, the second position, n is 2. t3, the 3 is the third position, n is 3. So we can never have a 0 position. We start with the position 1, second position, third position, goes to the end position. So this is the fourth position, and it goes to the in this case, the end position, and the end position is 45, given that the term is 5,896. So T45 is 5,896. Boom. So this is our answer. And this was 2 marks. Not too bad. So yeah, so I would give, if you get this is the right answer. If you indicate this is your right answer, and then for substituting, just doing your algebra, then you get your 2 marks. Okay. Yeah, so this is it for question 1. You get your full free 6 marks. Easy quadratic equation. But just a revision on what we've learned here. This is what you've learned. You've learned that the first equation, with the quadratic equation, you have your Tn. Tn is equal to an squared plus bn plus c. That's a quadratic formula. And we know that you have the first term, second term, third term, fourth term, till the last term. Let's call it Tn, right? And then you know that this is what you need to do. You need to always say T2 minus T1, T3 minus T2, T4 minus T3 to get your first difference. So this is your first difference. Let me write this. This is your first difference. And then you do it again for your second difference, right? And then we are being told that this one, need to remember that 2a is equal to this, and then 3a plus b is equal to that, and a plus b plus c is equal to your first term. Why is that? Because you're gonna have p to solve for a, b, and c, and also do other stuff. If you understand this, you understand everything about quadratic sequencing. Another thing that you've learned was a quadratic formula. Just need to remember that it's only applicable on the quadratic if you see a quadratic equation, and a quadratic formula says that then you're solving for x in this case, so x equal to minus b squared minus 4ac over 2a, and b, this is b, this is a, this is c. So you have to be able to identify that in your equation that you're playing around with. And that's it. That's everything that you've learned so far. Again, thank you for joining. This is question 1. For next video, I'll be doing question 2. This is how question 2 look like. 10 marks. Let's go. Awesome.